Today we're going to take a look at 5.06, adding and subtracting rational expressions. Those are our goals, adding and subtracting rational expressions, but sometimes they're going to have common denominators, but sometimes they're uncommon. So let's rewind for a second. What are we talking about when we talk about expressions? Well, we're talking about a group of numbers and variables and things like this that have no equal sign, right? And what does it mean to be rational? Well, rational has the word ratio. Ratio is a relationship between two things. So we're talking about fractions, okay? So from your memory and your experience with adding and subtracting fractions, is adding and subtracting them easier or harder with a common denominator? Well, hopefully you remember that if the denominator is common, that makes our lives easier, but sometimes it will not be common, and we have to know how to work with that. Okay, so we just talked about what makes this expression rational, but take a look. We are dealing with polynomials within fractions today. But before we actually add and subtract some of these expressions, let's refresh our memory to increase our confidence, because right now you might feel like this. Maybe that's the type of experience you had when adding and subtracting fractions. And my goal for you today is to feel more like this by the end of our time, boosting your confidence and making you just feel better about it. But you really boost that confidence from practice, from studying videos like this and other videos, other resources out there, but also very much so practicing the math. Okay. So let's do that. Let's start with some practice here. Try it out. Do you know how to add these together? Well, here we have a common denominator, right? That makes our lives easier because once you have that common denominator, all you do is add the numerators together and you have your answer as long as it's fully simplified, which it is. Now, let's break this down a little bit more. Why do we want a common denominator? Well, you need these two things to relate. Here's one way to think about it. You could think about the denominator as the last names and the numerator as the first names. So maybe this is a brother and a sister, and they share the last names. Okay, that's one way that might stick with you. Another way to think about this is in a real life example, like having a pizza, or let's say a bag of marbles. Let's say you had a bag of marbles that could fit 7, but you only have 3. And ultimately, you want to know, if I added 2 more marbles, how full would that bag be? Well, it has to be a bag that's the same size, doesn't it? That holds up to 7 marbles. So we need those denominators to be common. That's the big idea anytime you add or subtract fractions. Now that you know that, give this one a try. The common denominator, hopefully you see, is 12. So here's a few ways to think about it. You could think, well, I'm looking for the least common multiple between 4 and 3. And if you're not sure, you could list out the factors of 4 and then 3. So we go with 4. Let's start with 2, I suppose. So 2, 4, 8, 12, the list goes on, right? Actually, let me move this. So the least common multiple is also going to be the least common denominator. So those are the multiples of 4. Now let's look for multiples of 3. We don't care about 1. Everything other than 0 has a factor of 1, so that doesn't help us. And the first number, the smallest number also that we find to be the same, is 12. Well, I don't know about you, but I don't want to write out these factors every single time. So here's a faster way to do that. So let's say I don't want to do that, okay? Instead, what you can do is you can take your denominator. Let's say you have 4, so I'm going to get rid of all this. So you have 4 on the left, and I'm going to list out all my factors that I have of 4. Just the ones that I have that make up this denominator. Then all the factors of my other denominator, 3. Now the big question is, what is down here in this list of factors that isn't up here? Well, clearly we can see there's a 3. So we're going to add it in there. Now, what about on the bottom? Same question. What do you see up here that's not down here? Well, there are 2 2's, aren't there? And right here, look what we found. Well, 2 times 2 times 3 is 12. 3 times 2 times 2 is also 12. Same factors gives you the same product, which is our denominator. So here's how we use this. We're going to take 3 and we're going to multiply our denominator of 4 by 3. But can I just multiply the denominator by 3? No, you've learned a long time ago that you need to also multiply the numerator by the same. But why? Well, you've heard me say before, this is a fancy form of 1. And you can multiply any fraction by 1 because you're not changing the ratio, right? If you had 3/4 of a pizza, and then you have 3/4 of a pizza. That's it. You're not magically just having more pizza, right? You're not just saying, I'm going to multiply this by this and make more. No, we're not doing that. So let's take a look at what this fraction would become. Well, it would become 9/12, right? Well, take a look at this. There we have 9/12. Interesting. You see what I mean? There's still the same ratio. The numbers are just bigger. So that's a little refresher on why we multiply by a fancy form of 1. Okay, and then over here, you're multiplying by whatever we had on the right here that we added on. We added on 2 2's. So I usually don't include this part, just the factors. Okay, well, 2 times 2 is 4. So that's what we're going to multiply over here. So we get minus 8/12 to give us 1/12. What do you think about this technique? If you like it, great. If you don't, you can use something else. But when we get into polynomials with variables and other things going on in the denominator, you might want to use this. We'll see. Okay. Something else that is very helpful to know is, well, I just multiply this denominator by the other one and this by the other one. That worked out very nice and simple in this situation. But with polynomials, it's not always that straightforward. It can be, but we'll get there. Okay, so these are polynomials being subtracted. Of course, we need a common denominator, and we do. That's always what you want to check for first. Do I have a common denominator? Great. So take a moment now to look over my work and check it. See if I got it correct or if there's any mistakes. Now that you've had a moment to check, let's take a look. Well, I have a negative sign here. So that's like a -1. So -1 times x gives us -x. -1 times 6, -6. And because we're combining these, we're going to also include that x squared over here. Okay? Or You could have written this all over the same numerator like this. You could do x squared minus x plus 6, and then you would still be distributing that. Either way, you're going to get this, okay? Now we have a numerator that's not factored. The denominator is, numerator is not, so we're gonna try the x method, and fortunately it works. So we write out our factors, and now my question is this fully simplified? This answer here, and why or why not? Well, we have common factors, don't we? So it wasn't fully simplified, but now it is. Will there be domain restrictions here? No, there is no x in the denominator, so no domain restrictions. Okay, go ahead and give this one a try. What do we check for first, and then what do we do after that? We check for common denominators first. Sweet, we have them. So we work out that numerator. Well, we have positive times positive, positive times positive, so not much is going to change, is it? So we're going to put everything together. We have some like terms here. 2x plus 3x. And then we just have negative 4 plus 2 left. And is there anything left to do? Could I factor out a GCF of these? Could I cancel out then anything? Actually, no. Okay, so the answer is going to be A. But if you also wanted to mention domain restrictions, which you should be in the habit of doing, well, if I set this factor equal to 0, x would clearly be 0. What about this one? Well, 1 minus 1 would give me 0 as well. So domain restrictions are 0, but also positive 1. Unlike denominators, okay? So this is getting into what I hinted at before. And this is where a lot of mistakes start to happen, where now we have variables and we need to multiply and find other factors. What I said before is, sure, you could take this denominator and multiply it by this one and vice versa. We could do that. We could go, okay, multiply all this times x squared over x squared. And you can multiply this by 5x over 5x. And it would work out. But that's doing even more than you actually need to do. Just because it would still work, but you don't need 5x cubed as a denominator. You just need 5x squared. So I'm going to do the same method I did before here, where I'm listing out the factors of each denominator and then asking myself, what's missing? Well, on factors of x squared, I have 2 x's. Here I only have 1. Factors of x squared, I have 2 x's, but I don't have a 5 that I have in my factors above. So I'm going to multiply this times x over x, and this times 5 over 5. So 2x over 5x squared. And then distributing, we're kind of distributing backwards, right? We have positive x times 5, right? And we have positive 2 times 5. Well, we can just put this all together, combining those like terms. And there we have it. Can't be simplified. Domain restrictions, well, if there was a 0 where x is, everything would be 0. Now, I'm going to rework this problem the other way that I mentioned earlier to show you that it works, but also because maybe you find for yourself that it results in less mistakes. Let me erase what we have, but I'm going to keep our answer to show that we're going to get the same thing. So let's move that there, and here we go. So if I just said, I don't want to mess with all this and make mistakes, I just want to multiply top and bottom by x squared, multiply top and bottom here by 5x. Well, I'd get 2x squared over 5x cubed. Then I'd get 5x squared plus 2 over 5x cubed. Add those like terms, 7x squared plus 2 over 5x cubed. Okay, this is a situation where I'm going to need to do more work because I have a quadratic now up here. So I need to use the x method. -7 times -7 gives us 14, and it also, actually, is that going to work? Let's see. So we need these both to be positive or negative, and we need them to be the same because they need to add to 0 because there was no x term. So that's actually not going to work. So this is going to take quite a bit more work, okay? So I would suggest sticking to the original method that we use. Just proving that this way saves you time and work. Okay, well here, what kind of denominators did we have? One term, monomials, right? Here we have binomial, binomial, nothing to worry about. We're going to solve it exactly the same way as the previous problem. Write out your factors and ask yourself, what's below? That's not here. What's above? That's not here. There it is. So that's what we're multiplying. And in this case, yes, you are multiplying by exactly the opposite denominator. So give yourself a moment now to practice this. There's a little distribution going on here and on the right. So to avoid mistakes here, I'm going to first multiply what's on the left. And then I have this, my denominator. Now, I'm going to put my numerator all together, but I'm going to write it like this. I'm going to do -1 times x plus 2. That way I'm doing it like this so I don't forget this minus sign. -1 times x plus 2. Okay? Don't forget your signs. So what do? We have x squared minus 2x minus x minus 2. Now we're getting close. Okay, combine those like terms. We get this here, and look at that. We have a quadratic in the numerator. What's going to happen? Well, we got to try to factor that, don't we? So we're going to use the x method again. And only factors of 2 are 1 and 2. You could switch those around, make them positive and negative, do whatever you want, but you're never going to get what you need. It's never going to work out. So this is actually as simple as it could be. If these were both negative, yes, they would add to -3, but they would multiply to +2. if you add domain restrictions, 2 and -2. Which you should get in the habit of that, but you won't always be asked to include domain restrictions. All right, let's go ahead and move on. Here we're adding. This is a great chance for you to practice what you've learned, and there's multiple choice options on the right. So what do we have? Well, here there's an x plus 1, there's an x plus 1. Here there's an x minus 3, but here we're missing an x minus 3. So we are only going to actually multiply one fraction, aren't we? Because this denominator has everything we need. So we multiply. And we're adding, and we have the same denominator, right? So we can just say plus this. Everything's positive, so not much to worry about in terms of signs. And what do we have? Well, we now have x squared plus 2x plus 1 over this. Okay, do we see that in our answer choices? No, that's a sign we need to simplify more, which hopefully means the x method is going to work this time. We haven't had much luck yet. 1 times 1 is 1, 1 plus 1 is 2. Amazing. X plus 1 times x plus 1. Look at that. We're going to have something finally that cancels out, leaving us with x plus 1 over x minus 3. All right, you're doing great. We're almost there. We have our exit ticket. This is actually the most complex problem of the day, but it's nothing you can't handle. It's the most complex because we don't have common denominators, and this one on the right is not factored. So we need to factor first. Let's do it. You should have practiced this together. If you haven't, pause the video now. It's not too late. Okay, this one's easy. 3 times 3 is 9. 3 plus 3 is 6. So let's write out what we have. 4 over x plus 3. And this all stays the same. We only had one polynomial that actually had to be factored. And this is quite nice. We can just see that there is an x plus 3 needed on the left. And I'm going to move this over so everything is easy to see. 1 second. Doesn't want me to move it. There we go. All right. So multiply times this over this. So we get 4x plus 12. And what do we have? We have minus all of this. We're going to use parentheses because remember that minus needs to distribute to everything. So we have 4x plus 12 minus 2x plus 1. We know our denominator is going to be x plus 3 squared. So we know b is out. Okay. And might as well write it like that now. So what does this simplify to? We have 4x minus 2x, and we have 11 plus 1. Do we see that numerator? Yes, we do. Amazing. There it is. So that's it for 5.06. As always, there's the OLS practice resources, and watch this as many times as your heart desires. Until next time.